Hey everyone and welcome. Today we're going to pull back the curtain on AI agents. We're going to show you that building a really useful, production-ready agent isn't some kind of magic trick. It's all about solid, deliberate engineering. So let's jump right into the architectural blueprint. Okay, so here's the core problem we've got to tackle. A large language model, an LLM, is basically a brilliant brain trapped in a box. I mean, it knows a ton about language from all its training data, but on its own, it can't check your order status, it can't book a flight, or even see if a product is in stock right now. So the big question becomes, how do we get this amazing brain out of the box and give it the power to actually do things in the real world? So how do we do it? Well, we build a bridge. We create a connection that lets the LLM talk to all those external systems. And you know what that bridge is made of? Something we call skills. This is the very first and probably the most important phase of getting an agent deployed. So what is an agent skill, really? For anyone new to this, the easiest way to think about it is like a tool in the agent's toolbox. It's a very specific instruction manual that tells the LLM, hey, here's exactly how you need to ask the weather API for the forecast. This is what gives the agent its hands and its eyes. And you gotta know this instruction manual has to be super, super specific. Every single skill is built from 4 essential parts. A name, so it knows what function to call. A description, which is crucial for telling the agent when it should use this tool. The inputs it needs, like a city for the weather. And the outputs, which describe what kind of answer it's gonna get back. If you miss even one of these, the LLM is basically flying blind. Okay, so let's see what this looks like when concept becomes code. This JSON schema right here, it's the strict machine-readable blueprint for a skill that looks up an order status. Just look at the parameters it defines, order number and customer email. And I want to be really clear here. This isn't a suggestion. It's a non-negotiable rule. The agent cannot and will not move forward until it gets that exact info from the user. All right, so this all comes together in what we call the execution lifecycle. It's a 4-step dance. First, a user asks a question, and the agent selects the right skill and spits out that structured JSON. Second, that JSON is what triggers the actual code to go talk to a database. Third, the database sends back the raw data. And finally, the 4th step, the LLM takes that raw, kind of messy data and turns it into a helpful, easy-to-read answer. It's a complete circle, from intent all the way to a useful action. Okay, so, great. Our agent has hands and eyes. It can act. But let's be real. The world is a messy place, right? APIs fail, users type in weird stuff, databases crash. This brings us to the next critical phase for deployment. We have to build an immune system for our agent, and we do that with guardrails. Think of these guardrails as a 2-part defense system. First, they're preventative. They stop bad inputs before they can ever cause a problem, like making sure an email address is formatted correctly. And second, when things inevitably do go wrong, they act as a translator. They take those cryptic, ugly system errors and turn them into useful context that the LLM can actually understand and do something about. Let's just zoom in on this out-of-stock error for a second. This is huge. A lazy system would just come back and say, nope, sorry. But a good guardrail gives a clear instruction. Do not just say no. Go check for other colors or sizes. The result? A super helpful response that turns a dead end into a potential sale. And that right there, that's the difference between a cool demo and a system that's actually ready for production. Awesome. So now our agent has tools and it has an immune system. But what happens when you don't have just one tool, but like dozens of them? How does it figure out the right one to use, or maybe even a combination of them, for a complex question? Well, for that, we need an orchestrator, a global brain. That's where the orchestrator comes in. You can think of it as the global brain of the whole operation, often managed in a central file. It's basically the project manager. It looks at what the user is asking for and intelligently routes the request to the correct skill or skills. So if you ask, hey, check on my order and what's your inventory look like, the global brain knows, that's a 2-parter, and sends it to 2 different skills. And this brain, this orchestrator, it really has 2 main plays it can run. First is parallel execution. This is for your and questions. Check my order and my inventory. It runs both tools at the exact same time, which is way more efficient. The other play is sequential execution. This is for your if-then questions, like if you have these shoes in stock, then place an order. It has to get the answer to the first part before it can even think about the second. And this diagram really lays it out visually. You see that top path? That's parallel. 2 things happening at once, nice and fast. But that bottom path, see that little diamond shape? That's a decision point. That's sequential.
The agent has to check the status of step 1 before it can decide whether to go down the path for step 2. This logic is absolutely key for handling those more complex things users are going to ask.
So at this point, we've built a pretty capable tool user. But what if we want to build something that's truly autonomous? An agent that can reason its way through multi-step problems all by itself. To do that, we need to give it a way to think. This is where a framework like React, which stands for Reason and Act, comes into play. The best way to think about it is as an internal scratchpad. Instead of just spitting out an answer, the agent goes through a loop. First, it has a thought about what it needs to do. Then it takes an action, like calling one of its tools. Finally, it makes an observation of what happened. And it can run through this loop over and over again until it figures out the final answer. This return policy example is the perfect way to see this in action. The agent's first internal thought isn't just ask the user why they want to return it. No, it's smarter than that. It thinks, first, I need to check the delivery date to see if it's even eligible. So it takes an action, checks the date, and observes it's only been 14 days. Okay, now its next thought is, the date's good, now I can ask for the reason. This ability to reason in steps is what makes it a truly autonomous agent. All right, deep breath. We've covered a lot, right? We've got our skills, our guardrails, the orchestrator brain, and that React thinking loop. Now let's put all the pieces together and look at the final master blueprint. And this is the whole shebang, the complete picture. You can literally trace the journey. The user's request comes in and hits the global brain for orchestration. That brain routes it to the React loop, that internal scratchpad. The loop then decides which specific skills to use, and those skills are protected by the guardrail immune system before they're allowed to touch any external systems. Finally, the answer comes back out to the user. Every single piece we talked about working together in harmony. So if you remember anything from this, remember these 4 architectural pillars. The skills are the bridge that lets the agent act in the real world. The guardrails are the immune system that keeps those actions safe and reliable. The orchestration is the global brain that intelligently directs everything. And that React loop, that's the internal scratchpad that allows for truly autonomous reasoning. Look, these aren't just abstract theories on a whiteboard. These are the real engineering principles for building the next generation of smart, helpful, and, most importantly, reliable AI systems. Now you have the blueprint. So the real question is, what are you going to build?